Welcome to this solution video of paper 53 of May-June 2023 Cambridge International Exams Probability and Statistics 1. If you like this video, please give it a thumbs up, share with your friends and subscribe to my channel so that I can make many more videos like this. Let's start with question number 1. Two fair coins are tossed simultaneously until a pair of heads is obtained. That means we want to have two heads from both the coins. The number of tosses are taken as a random variable x. So they said until a pair of heads is obtained. That means this one is a geometric probability. What is that? You lose many times, and when you get success, you stop. That means there is a loss, and then win. So this kind of situation. So you can have many losses, but once you get win, you stop. Okay. So now there's asking in a part, state the value of expected value of x. Okay. So expected value of x is nothing for geometric probability. It has to be let's say ex has to be 1 over p, the reciprocal of probability of success. So what is the probability of getting two heads? So let's see what are all probabilities, what possibilities are there. We can get a head and a tail, we can get a tail and a tail, we can get tail and head, and then we can get both heads. These are the only four possibilities, and in every possibility the possibility of head or tail is half and half. So we can simply count them. There are four and one of them is a pair of head. That means the probability of success P is 1/4, right? And then we'll do here 1 over 1/4, reciprocal of 1/4 is 4. So expected value after which we will get a success is 4. That's what it means. Okay. The probability that exactly 5 tosses are required to get a pair of heads. Find the probability. So we want to find the probability that x is equal to 5. What it means that we get losses for 4 times, and then we get finally a success. Loss, there's a loss in before then we have a success, win. So what is the probability of a failure in this case? If probability of success is 1/4, probability of failure Q is 1 minus 1/4. So that's what we will do. 1 minus 1/4 is 3/4. Okay. So we'll get 3/4 to the power 4, and then we have success. So 3 to the power 4 is 81. 4 to the power 4 is 256, and times 4 1024. You may also convert it to decimals if required, if you want to, but this is fine. Find the probability that fewer than 7 tosses are required to get a pair of heads. So what it means that we may get a success in the first attempt, or second attempt, or third, or fourth, or sixth, but in these 6 attempts for sure we'll get a success. Which one, we are not sure, right? So what we can be sure of, that there is no failure for consecutive 6 times. So we can say that this is the failure, we are failing for 6 times. We will subtract it from 1, that ensures that we are not failing for consecutively 6 times, right? We are getting a success somewhere in between, and that's what we will evaluate now. 1 minus 3/4 to the power 6. So 1 minus 3 to the power 6 will be 729. 4 to the power 6 will be 4096. And that will be how much? 6 minus 7 to 6, 3, 6, 7 over 4096. And if we convert it to decimal, it will be 0.822. This is the probability. All right. Question number 2. Question number 2 says Anil is running for an election. Rather, he ran for an election, right? Okay. He received 40% of the votes. A random sample of 120 voters is chosen. Okay. So N is 120. P, probability of him being successful is 0.4. Use an approximation. So we always use normal approximation here to find the probability that between 36 and 54 both inclusive voted for Anil out of those 120. Yeah. So what will we do? We'll do normal approximation. So we'll need some visualization first. Okay. So we need a mean first, right? So mean is N times P. N is 120, P is 0.4. So 120 times 0.14, 12 times 4, 48 is mean. We want between 36 somewhere here and 54. Let's see, make it closer. So we want between these two numbers here. This area we want to find out. That means 36, both inclusive, right? So 36 has to be inside here, 54 has to be inside here. Since this number of voters is a discrete number, we cannot, we are using approximation of normal approximation, which is for continuous data. So to include 54 here, we will change our limit to 54.5. So that if I find a probability below 54.5, it includes 54. But 36, I don't want, I want it to be on upper side, not down there, because our table I'm going to use, this one, includes only the below area. So that means we will have to use 35.5 here, so that this area is excluded. Okay, and 36 come inside the area I want. Okay. So let's start with 54. What is the probability that we get less than 54? So I'll get this and below up to here, the whole area. Out of that, I will find this area, this small white uncolored area, and then I will subtract it and I will get the area I want. So let's start with 54. Rather, we will use 54.5 for this. So first we need Z score for this. So Z score for 54.5 minus 48 divided by standard deviation, and mean is NP, standard deviation, let's say sigma, is square root NPQ. I am not going to calculate it here. I will straight away write here so that I get closest possible Z score. So N is 120 times 0.4 is probability of success, and probability of failure will be Q. 1 minus 0.4, which is 0.6. 0.6. I will just put this in my calculator and I will get my Z score. Okay, what I'm getting here is 1.2112. Okay, so let's find probability for Z less than 1.211. We'll not use this because our table is for 3 digits after decimal. So let's see, 1.211. 1.21 is 8869, and next one is 2. This 2 will be added to the last digit here, so it becomes 0.8871. That is the probability of less than X being less than 54.5, or Z being less than this, which is 0.8871. Okay, done. Now I have to find less than 35.5, this which I have to remove from this one. So let's find Z for X being less than 35.5. So we'll get 35.5 minus 48 divided by square root 120 times 0.4 times 0.6, which I'm getting as 2.3292 and more. So I'll ignore this one also. I'll just take this Z score, but it is negative. If you say 35.5 minus 48 will give us negative, and which is rightly so, because it is less than the mean, so we'll get a negative Z score. But probability, if I want that it is less than Z is less than minus 2.329, I'll subtract the probability of this Z score, this positive Z score, from 1, and I'll get for negative, right? That's what we do, because we do not have any negative Z score. If you see here, Z starts from 0 and 2.9, they're positive, there's no negative, so this is how we use it, by making it 1 minus. So we'll look for 2.329 now. So 2.3 to 0.9898, and 9 in the same line is 2. So 0.9898 and 2 will add to the last digit, so it becomes 0.99. 0.99, which is 0.01. And finally, the question was, what is the probability that he got votes between 36 and 54 both included? So we will write probability that X is between 36 and 54 both included is this probability 0.8871 minus 0.01, which is 0.8771. We can round it off to 0.877. That's the final answer. Question number 3, A part. The random variable X has values 1, 2, 3, 4. Okay, so X is equal to 1, 2, 3 and 4. It is given that the probability of X equal to small x. If X is equal to 1, that means this X will be replaced by 1. That's what this whole thing means. So let me do it. Probability of X equal to 1 will be K times 1 and then 1 plus A. This is what it means, which comes out to be how much? K and 1 plus A. Right? And similarly we'll do for 2, 3, 4 also. Let's see what they are saying. Okay, given that P x equal to 4 is 3 times probability of x equal to 2. Okay, that means we'll have to do for all. So okay, done. So now this is the equation which will help us to find one of them. So let's do it here. Probability of x equal to 4, this one, which is 4k 4 plus a, is 3 times probability of x equal to 2, which is 2k 2 plus a. Alright, so I think we can divide both sides by 2k to get rid of k, and this will simplify. So this will be 2 and this is gone. So we are left with 2 4 plus a, and then we have equal to 3 2 plus a. So 8 plus 2a equal to 6 plus 3a. So let's rearrange, bring 2a with 3a, so it will become 3a minus 2a here and 8 minus 6 here, so a comes out to be 2. And they said they are to be found out, k and a. So a is done. We are left with k. For k, what will we do? Let me use the fact that the probability, all probabilities in a situation, they add up to 1. That means if I add this and this, all 4 probability, because these are the only 4 possibilities of outcomes, their sum will be equal to 1, and that's what I'm going to do now. So k is unknown to us, but a is known now, which is 2. So 1 plus 2, 3k, 2k, and then we have 2 plus 2, 4, 3k, 3 plus 2, 5, 4k, 4 plus 2, 6, and their sum has to be equal to 1. So how much that will be? 3k plus 8k, 11k, plus 15k, 26k, and plus 24, 50k, equal to 1, and that gives us k equal to 1 over 50. We got both a and k. Okay, next one says draw the probability distribution table, obviously for giving probabilities as numerical. Okay, so we'll need the first part. Okay, so let's draw the probability distribution table. So we'll say x first. So we have 1, 2, 3 and 4. Okay, probability that x is equal to x. So it was how much? 3k. 3k was the probability of, let me show you. We got this 3k from here. Yeah, so 3 times k is 150, so 3 times 150, 3 times 50, sorry, 3 over 50. 3 times 1 over 50 will be 3 over 50. Next we will have 8k, so 8 over 50. Then we have 15k and 24 over 50. So if you want, we can simplify this. This can't be, this is okay. This is can be written as 4 over 25. This can be written as 3 over 10, and this will be 4, can't divide this, so 12 over 25. If you want, you can write the simplified forms only. This is the probability distribution table given as numerical fractions, and I've done that. Let's do last one. Given that the expected value is 3.2, there was no need to give it, but they want to save our time, that's why they have already given this. We just have to find variance. And what is the formula for variance? Variance is sigma x square p x equal to x minus square of expected value. This is the formula, and that's what we're going to do. So this is small x, so we'll take 1 by 1. So 1 square, sigma means add them, okay? So 1 square, and probability of 1 is 3 over 50, plus 2 square, 8 over 50, that's the probability, plus 3 square, 15 over 50. I'm not writing the simplified because the denominators will be same. It will be easy to add. I'm doing it mentally, that's why I prefer that. Otherwise you can use your calculator. 24 over 50. Okay, minus 3.2 was the expected value square. Okay, so this will be how much? 3 over 50 itself. Let me write all as one fraction because their denominators are 50, all of them. So 1 square times 3 is 3, 4 times 8 is 32, 9 times 15 is 135, 16 times 24 will be 384, minus 10.24 will be the square of this, and just put this in a calculator, you will get it. So 35, 170, 554 over 50. Is it coming out to a negative? I don't think so. Let's see. By the time I use my calculator to do this, I would request you to like this video, share with your friends, and subscribe to my channel. That will be a good motivation for me to make many more videos. Thank you very much. And what I got is 0.84. That's the variance. Question 4. The times taken in minutes to complete a race by 19 cyclists from two clubs, Cheetahs and Panthers. So Cheetahs and Panthers are shown in stem and leaf diagram back to back. Find the median and IQ or interquartile range of the times taken by Cheetahs, the first ones. Okay, so they are 19, right? For median, we will add 1 to it and divide by 2. That position, which is 20 divided by 2, 10th position will be the median. So count from up or down, doesn't matter, but you should always try to count from the smallest one. 78 is the smallest one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 99 minutes is the median. Okay, now we want to find IQR. Interquartile range is upper quartile Q3 minus lower quartile Q1. Let's talk about Q1 first. Q1 is nothing but the median of the lower half, excluding median. Okay, we have to exclude median, so remove this 99 and find the median of the remaining 9 which are below this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So their total 9, their median will be 9 plus 1 divided by 2, which is 5th number. 5th in the sequence will be the Q1, which is 1, 2, 3, 4, 5. We have to be very careful, but you have to count from here because they are the lower numbers. This is 80, this is 82, this is 83. This is 88, so we can't count from here if I counting from lower one. So 83 is Q3. Similarly, the 5th from the top will be the Q3. So I'm doing this first, then I have to start from here because 119 is more than 112. So 1, 2, 3, 4 and 5. 106 is Q3, and if we subtract them it comes out to 23 minutes. This is the IQR interquartile range of Cheetahs, and that's what they asked, IQR and median. B part, the median and IQR of Panthers 103 and 14. So there was no need to give again, they have saved our times by giving it to us. Okay, 40 minutes respectively. Make the two comparisons between the times taken by the two. So IQR is 23 here and 14 here. So first observation could be that the cyclists of Panthers timed closer to median overall because their IQR is 14, very small, and this is very wide. That means they were wide around median and they were close enough. So closer overall as compared to Cheetahs. Second, since the median is higher here, yes, and it is 99 for, where is it, 99 minutes for Cheetahs. So the cyclists of Club Cheetah were faster than Panthers because their median is so low that most of them timed lesser. and that's why they were faster. These are the two statements according to comparisons of the two clubs we can make. All right. Another cyclist, Kenny from Cheetahs, also took part in the race. So they are 20 now. The mean time taken by 20 cyclists from Cheetahs is 99. Okay. Find the time taken by Kenny to complete the race. Okay. So mean of any group is the sum of all data, or in this case we'll say all times, divided by number of cyclists, right? Number of cyclists we know is 20. Sum of all times will be sum of 19 cyclists plus Kenny, because we don't know Kenny's time, so we'll have to separate him from others, and that mean is how much? 99 minutes, right? So this is an equation which is there for us now, and we can just multiply this by 20 here, multiply this also by 20. Why? To cancel this 20. So sum of 19 cyclists, we'll have to add them and then plus Kenny. So I will write those here, plus let's call it Kenny, and 99 times 20 will be 1980. So let me calculate the sum of all the other cyclists, 19 of them, of Cheetahs, right? Cheetahs. So by the time I add all of these, now let me show you how I'm doing. First of all, 78 is the smallest number, right? 78, then 79 plus 80, this 80, and I will add all of them till 124. So this will give me the total sum. By the time I do this, I would request you to like this video, share with your friends, and subscribe to my channel so that I can make many more videos like this for you. It came out to be 1862, and this is what we're going to use here. So Kenny's time will be 1980 minus 1862, which is 118 minutes. Question 5. Jasmine rolls 2 ordinary fair dice. Ordinary and fair dice. Ordinary means it's 6-sided. Fair means all faces have equal chance of coming simultaneously, and notes the outcome. Okay. The event A, the sum of the two outcomes is less than 6. Okay. Event B, the difference between the two outcomes is at most 2. Less than 6 means 1 to 5. At most 2 means 0, 1 and 2. Okay. Determine whether or not the events A and B are independent. Okay. So for being independent, their intersection should be the multiplication of their probabilities. The probability of their intersection should be equal to the multiplication of their probabilities. If it is the true case, then they are independent. So let's find all three with the help of a table. Let me draw a table where I have to draw the sum and difference both. So I'll have to give some space because both of them will be in one table. So 6 faces of the first die, 1, 2, 3, 4, 5 and 6 faces of the second die. Okay, let's first write their sum. Okay, so 1 plus 1 is 2, 1 plus 2 is 3, and so on. I will fill up the whole table now. So I have written their sums. Now with this I will write this difference. What is the difference between 1 and 1? 0, right? So let me write 0 here. What is the difference between 2 and 1? 1. Then this is difference of 2. So I have completed the whole table. The yellow colors are the sums and the white colors are the differences. Okay, so let's first look at PA. A is the sum of the events, sum of the two outcomes is less than 6. Sum means look at the yellow parts. Is this less than 6? Yes. So let me circle the ones which are less than 6. These are less than 6. I forgot to write here how much it will be. 1. Yeah, 3 minus 2 is 1. Okay, this will also be 1. Okay, so these circles are the sums which are less than 6, and all of them are more than 6 or more. Yeah, so how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 cases out of 36 where the sum is less than 6. B, the difference between the two outcomes is at most 2. So I will circle where the sum is at most 2. So 0 is included, 1, 2. These 3. Not 3, okay? At most 2 is this one. So 3 cases here, then 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This should be 3. So 24 over 36. Now, how many of them have both circles for A and B, both of them? So this is 1, this is 2, this is 3, not this one. 4, 5, 6, 7, 8. No. Okay, 8. So 8 out of 36. So let's see if they are equal. So 2 and 3, this will be gone. This will be how much? 5, and this will be 18. 9. So 8 over 36 is not equal to 5 over 27. They are not equivalent. So we can say that events A and B are not independent because the two sides didn't give us same fraction. Okay, let's go to question B part. Probability of B given A prime. A prime means A does not happen. So according to our formula, it will be probability of B intersection A prime divided by probability of A prime. So probability of A prime is easy because we know probability of A, which was 10 over 36 here. So A prime will be 1 minus 10 out of 36. Now we will look at the circle where B is circled but A is not circled. And we can separate these because here all of them A is separated. So we will put a line here where A is circled so that we count only below this line now. Okay, only second circle is circled, so we'll count them. This is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, and this is already gone. This is not circle, right? 10, 11, 12, 13, 14, 15, 16. So 16 out of 36. So it becomes 16 out of 36. divide by 26 out of 36. That's what 1 minus 10 over 36 is. 36 and 36 can cancel, so 16 over 26 or 8 over 13 will be the similar form of this one. Question number 6. The mass of grapes sold by shop can be modeled by normal distribution with mean 28 kgs. Okay, so let me visualize this. Let me draw it here. So this is the model. The mean is 28 kg. Okay, on 10% of the days less than 16 kg. So 10% will be very less. So this is 10%. You can write it as probability 0.1 and 16 kg is this one are sold. Find the standard deviation of the mass of grapes sold per day. We have to find standard deviation. Okay, so 16 kg is less than 28 kg. That means the z-score will be a -1. So let's see what is the z-score for this. According to the formula, 16 minus 28, obviously negative, divided by standard deviation, which is unknown. Now if we find z-score, we can find standard deviation. We know that this is 0.1. that means the area above 16 kg, the probability will be 0.9, correct? So for finding the z-score, we can use 0.9. 0.9 is the probability that let's say the x is the weight is greater than 16 kg. Probability of greater than 60 kg is 0.9. So what will we do? We'll find the z-score for 0.9 and then we'll put a negative in front of it because we know it is a negative number. So let's go back to our table, and 0.9 probability, this whole table shows the probability, and 0.9 will be 8997. This is the closest of 0.9. We need 3 more to add to 7 so that it becomes 0.9. So there is no 3, so we'll see in between what 1 and 2. So our z-score becomes, because it's a lesser, -1 point. What will that be? 2, 8, and between 2 and 4. So we between 1 and 2 will be 1.5. -1.2815 is the z-score we are going to use here, and then we can find standard deviation. So -1.2815 equal to -12 over sigma. Yeah, and so sigma will be -12 over -1.2815, which is negative and negative can cancel, and let me use calculator for this. 12, it comes out to be 9.364. so let me use 9.36 as standard deviation. Okay, let's go to the second part. The mass of grapes sold on any day is independent of the mass sold of any other day. Okay, they are independent. 12 days are chosen. Okay, so 12 days are chosen. Let me see here. Where is it? At random, find the probability that less than 16 kg of grapes are sold on more than 2 days. Okay, so having a mass less than 16 kg is success. So P becomes 0.1. That's what they've given. And Q in that case will be 1 minus 0.1, which is 0.9, is the probability of failure. And they are independent, and there are limited number of days selected. That means we can use a binomial distribution, probability distribution in this case. Okay, so what will we do? They want probability that X is more than 2 days. which means probability that X is 3 days or X is 4 days or 5 days or 6 days up to probability X is 12 days, which is a very long list. So I would rather do this. We'll subtract the cases which are not in this list. We don't have 0, we don't have 1 and 2. So we'll subtract probability of 0, probability of 1 and probability of X equal to 2 from 1, and we'll be left with the probability of this whole list. So let me substitute them by the formula. Probability X equal to 0, that means out of 12 there are 0 successes, so probability of success is 0.1 and probability of failure 12. All 12 days we get more than 16 kg, not less than 16 kg, that's what it means. Then 12C1 and 0.9 to the power 11 plus 12C2 0.1 to the power 2 and 0.9 to the power 10. Just keep in mind that 10 plus 2, 12. It has to be 12 all the time. 11 plus 1, 12 plus 0, and these numbers must match. Okay. So now I will value them one by one and right here. So this is what it comes out to be. These threes and 1 minus 0.8891 is their sum. And if we subtract from 1, we'll get how much? 9, 0, 1, 1. Or you can write 0.111 is the probability that you will have less than 16 kg on 2 or more days. Do we have another part? Yes, we do. In a random sample of 365 days, on how many days will the shop sell grapes within 1.3 standard deviation? So let me redraw this. This is 28. We want 1.3 standard deviations on both sides. 1.3 here and 1.3 here. So that seems easy because we can find probability of this one and we'll just double it. This, whatever is this probability, we'll double it because both sides the normal distribution is always same. So for 1.3, what is the probability? 1.3. 1.3. The probability is 0.9032. Okay. So it means that the probability which is below this 1.3, this whole is 0.9032. That means the probability above 50%. This is mean, above mean, till mean we have 50. So from 9032, so the probability between 0 z score and 1.3 will be 0.9032 minus 0.5, because up to here we have probability 50%. We'll subtract this, which comes out to 0.4032. And now the probability that it is between minus 1.3, which is below mean, and 1.3, that means we include this 1.3 as well. It will be double of 0.4032. So the answer will be 0.8064. However, the question was that how many days, on how many days will the shop sell grapes within this? So we got the probability. So expected number of days, we can say EX will be equal to NP, total number of days multiplied by probability, which is 365 times 0.8064. So that comes out to be 294.33 days. So we'll ignore 33. So 294 days are expected to sell grapes within 1.3 standard deviations of the mass. Question 7. A part. Find the number of different arrangements of the letters in the word Casablanca in which two C's are not together. We don't want them to be together. Since there are just two of them C's, so let's take the opposite case. Let them be together. So C and C, they become one body and they move together. So we'll count them as one. Remaining are 8 more letters. 1, 2, 3, 4, 5, 6, 7, 8. Right? Since we have counted C's as one body, so they become total 9 letters now. So 9 factorial is the ways they can be rearranged. But out of these 8, 4 are A's. 1, 2, 3 and 4. Right? So we'll have to divide it by 4 factorial, because they can, even if they change their places A's, the arrangement will be same. So we have to divide by 4. These C's, even if they change their places inside, doesn't change the box. It still remains CC. So this is the cases when they are together. But the question is, they should not be together. Right? So what will we do? We will subtract it from the total number of arrangements possible for Casablanca, which is there are 10. So 10 factorial. Divide by 2 C's. Even if they change their place, they will not change the arrangement. So 2 factorial and 4 A's. And we'll subtract the cases when they are together from the total cases, and we are left with the cases when they are not together, and that will be 60,480 arrangements. Alright, next one. Find the number of arrangement of 10 letters which have A's at beginning and end. So we have A at the beginning and A at the end, and then we'll have 1, 2, 3, 4, 5, 6, 7, 8 places to fill up in between. Okay, and exactly 3 letters between C's. Okay, so that's another condition. So let's say that one of the C's is here, right? So 1, 2, 3 places between them, and this is the second C, right? Exactly 3 letters between those two A's. So this is one case. In this one case, let's see how can we put the others. So 1, 2, 3, 4, 5, 6, right? So they can be arranged in 6 factorial ways, the remaining ones, because A and C's are fixed in this case. But mind it, there are 2 more A's which are repeating, so we'll have to divide it by 2 factorials. This is just one case, right? This A and this A, which A's are these, doesn't matter. We don't have to select them out of those 4 A's. So any A's will do here. So this is the case, one case. Now this C is possible that this C goes here. So this C has to move here. That's another case. Second case. Third case, this C goes here, that C has to go here, because we need exactly 3 between them. And there will be one more case when C goes there. And so how many cases are there? One was this, 2, 3, 4. So 4 cases for which this will be the situation for each one of them, right? And that's why this will be our answer, and we can answer this by this will cancel. So 2 times 6 factorial 720 will be 1440 arrangements. Alright, final part of the final question. 5 letters are selected from these 10 letters Casablanca. Okay, find the number of different selections which include at least 2 A's, at most 1 C. So let me write A's, C's and others. So they said at least 2 A's, so it can be 2 A's or 3 A's or 4 A's. We can't have 5 A's because there's just 4 A's available. So at most 1 C, that means we can have 0 and 1 C. So with 2 we can have 0 and 1, with 3 we can have 0 and 1, and with 4 we can have 0 and 1. So how many left others? 3, because total we need to have 5. So 2 plus 3, 5, 2 plus 1 is 3, plus 2 is 5, 3 plus 2 is 5, 3 plus 1 is 4, plus 1 is 5, 4 plus 1, and they are already 5, so 0. So these two and these 0 C's or the 1 C, which of A's and which of C is here, we don't know. So it's not important because there's no difference between the A's. So we'll not even look at these columns. We'll just look for others, how many selections we need. In this case, it will be 4, right? In Casablanca, let me write Casablanca. So S is not repeating, B is not repeating, L is not repeating, N is not repeating. So these 4 are others. Out of those 4, we have to select 3 in this case, right? In this case, it will 4C2, 4C2 again, 4C1, 4C1, and 4C0. Just add these and they will be the answers. So 4C3 will be 4 plus 6, 10 plus 6, 16 plus 4, 20, 24, 1, 25 cases. So there are 25 such selections. That concludes the solution video for this paper 53 of May-June 2023. I hope you liked it. If you really did, please give it a thumbs up, or if you find any mistake in this paper, you can comment, and you can share this video with your friends, and please subscribe to my channel to motivate me to make many more videos. Thank you.